Okay, just a quick thing. We started our class on last, I think, 21st or 22nd. Okay. I mean, 20th was the introductory session. There was no class conducted. What should be the scope of our classes and all. We discussed all those things on 20th of December. Then 21st, we covered the first class. There we have discussed what is data, the different kind of data we can handle. That means the SQL, NoSQL, relational database, no relational database, all those kind of things we have learned on that particular day. Okay, I hope everyone can recall it. I mean, remember it. So those who are quite new, just have a quick look on your web. What is relational database and what is non-relational database? I'm just quickly repeating what is these things. So data can be represented in various way. So we are the data engineers. We need to handle the data. So we need to handle each kind of data for each purpose. Okay. So there are relational database means that the data are getting stored into tabular structure. There should be tables. In the tables, there should be various columns. That is table structure. When our table is ready, then we are good to insert record inside into that particular tables. So this is how relational database systems can store the records, store the data among itself. There is non-relational database as well. One of the example is, the JSON format. So there we are storing the data in not the structural way, just like in table format. If you can also find XML, YAML. So those kind of things are also non-structured data. Those are not relational database. Those are mainly called non-relational database. NoSQL is maintained to retrieve the data. Not only SQL is used there. And one more important topic we told, what is SQL? SQL is structured query language. Where we use SQL, this is kind of language when we are using relational database management system. So when we have multiple tables, we are setting up relationship between tables and all. Then to retrieve the data from the table, to create any information, any kind of data related activity we can perform through this SQL language. The same thing we'll be going to learn from tomorrow onwards. Okay. And this is very, very important for a data engineer to learn SQL thoroughly. Okay. So today onwards, we'll be only concentrating on relational database management system, RDBMS. Because I told for data analysis purpose, relational database is the most suitable one to start the things. Okay. So anyone is having any doubt before starting today's class? If there is any, please tell me. Any doubt so far from anyone? Okay, I hope no. So today we are starting with RDBMS part. We are not focusing on non-relational database as of now. We are concentrating on RDBMS starting from today. Over there, we will be covering what is normalization, data normalization in RDBMS. This is the main or primary focus area for today's part. Let me open the last slide as well. Last day, what we have learned, I'm just opening the slides. Is day one, day one. I'm opening the slides so that you can have a quick recap. So this is relational database tabular structure, and we are storing data in this format. There should be table, there should be columnar format, two columns are there, name and email, and we are inserting records. We can insert infinite records over there. And this is how we are storing data in non-relational database in this manner. Okay. So each time we can put this kind of key value pair combination. Per key signifying this kind of columns over here. Okay. Okay. We have one of the example of relational database you can see. So while storing the relational database, The data, as I mentioned, we need to store the data in tabular format. Over here, you can see there are four different tables, but each of the tables is having relationship between other table. So there are customer table, order table. There is a relationship between customer and order table with this arrow. You can see there is a common column. It's called order ID. Order ID is present both in order table and customer table. And by this common column, we can set a relationship between these two tables. Same for these two table, customer table and address table, we have a common column address ID. Okay. So in relational database management system, we should be having relationship between multiple table in this way. We should be having common column. This common column concept we also told what is primary key, what is foreign key in last working day. I hope you can remember it, but we quite new over here. This concept should be clear. What is primary key and what is foreign key? Let me repeat once more time because this is very, very important. So, as I mentioned, let me just, okay, someone is, I'm getting some noise. Can you please be on mute, everyone? Yeah, thank you. Okay, let me quickly repeat the thing once more time. What is primary key and foreign key in relational database management system? Because this is very, very important. So in this relational database management system, customer table and order table, in a particular customer table, customer ID should be always unique. I should put a particular ID to identify a customer. So that customer ID cannot be repetitive in nature in this particular table. So in that particular table, customer ID should be always unique. Whatever record I'll be pushing over here, the row identifier should be customer ID, which should be unique in nature. Okay. Similarly, for order table, order ID should be unique. In order table, product ID cannot be unique. In order table, order ID should be unique in nature. It should be consisting each of the order having one order ID. Similarly, in product table, product ID should be unique. Okay. But to set relationship between these two tables, I have introduced product ID over here as well. Otherwise, I cannot have a relationship between order table and product table. So product ID is working as a primary key in product table, but the same column is working as a foreign key in order table. Okay, so product ID is the primary key in product table and product ID is the foreign key in order table. And we are setting relationship between this primary key and foreign key because this is the common column. Similarly for order ID as well. Order ID is the primary key for order table. Order ID is the foreign key in the customer table. We are setting relationship by this common column, common key. This is primary key and foreign key concept. Primary key is very, very important, which will help a particular table to identify which particular thing is unique. Okay. The concept is clear for everyone. I'll be just jumping to the new slides today. Please respond whether it's fine or it's not fine. Then I'll be repeating myself once more time.
Yeah, it's fine.
Fine. Okay.
Yeah, we're good.
Okay, fine. Especially who are quite new for data, who are already experienced, I think there'll be no issue. This is very, very nominal concept. Okay, moving to the new slides. So today's slide is this. We'll be learning what is normalization, data normalization. So when we are storing data in RDBMS, we need to follow data normalization process. Okay, let's learn what is normalization process, what is not normalization process. Then we can learn how to make it normalized one. In the next slide, I just mentioned why we require normalization. So data normalization is a process of reorganizing the data within a database so that the users can utilize it for further queries and analysis purpose. This is one of the thing why we should do the data normalization things. But okay, there are other things as well. Duplication may be eliminated. So if the data is normalized in nature, the duplicate data inside the table will be eliminated. Okay. If the data is normalized in nature, the table space should not be big. I mean, the result data set should be very, very smaller. Okay. We can store the data in efficient way in database. Okay, you need to also think. So when we are purchasing a database, maybe we are purchasing the database from Azure, or we are just getting some host spaces with maybe 1 TB data, 1 TB of space we are getting from any host server. Okay, so when we are storing the data, but the data is not normalized in nature, it will took much more spaces. So very less data will occupy 1 TB data. I need to purchase another 1 TB again from the host server. So, but if we are just storing the data in normalized way, the data should occupy very less amount of spaces. So we can accommodate very large amount of data in the same 1 TB of terabyte of space. Okay, this is one of the important things why you should have the data normalization.
Can you give
Yeah,
me
tell me.
example for that?
Yeah,
Like
yeah,
sharing
we'll
a
be
data?
just learning these things in our demonstration. I'll be just showing these things.
Okay.
Okay. Uh, Minimize, avoid issues with data modification. If the data is normalized in nature, we can avoid issues. The query should be much more easier as well. So those are very, very important aspects why we should make the data normalized in nature. Okay. Let's learn what is normalized data. I mean, what is denormalized data? Let's quickly learn it. Then we can see. I have a quick example over here in Excel. Okay. So this is my first data set. I just keep it over here. This data set is nothing but I just took some data from some coaching center where I have student ID, student name, what particular courses they are learning, and what particular course fees they're giving to the coaching center. So I just collected this data set from some of the students. Okay. So, so this is a denormalized data. Why it's denormalized data? Let's see. Okay. The main thing why it's denormalized data, let me just quickly tell you. First thing, the data, any record cannot be duplicated in nature. Okay. So you can see the highlighted one, the yellow one are duplicated. So maybe mistakenly someone has inserted the same records in the database. So for denormalized data, there should be lots of duplication. Okay, so to make it normalized, the first step, we need to check the database and we need to remove the duplication. Okay, why it's duplicated? Maybe they haven't declared anything as a primary key. They haven't declared student ID as a primary key there. If they have declared this is a primary key should be always unique. So while inserting the same record again, there should be an error. The error should be thrown from the database itself. Why 12 is inserting again? Because 12 has already been inserted. Okay, so this kind of error should be thrown. I'm not telling how to make it. So first of all, we need to remove the duplication to make it a first normal form. Let me show what is first normal form. To make it denormalized to first normal form means we are just going ahead with one of the normalized way. So I'm just describing over here. I'll be describing what is first normal form, what is second normal form. Means We are just going ahead with the normalization process. Anyone is telling something I didn't get? Okay, maybe it's a noise. Okay, so to convert a denormalized data to first normal form, first step should be, okay, first there are two steps we need to check, and we need to convert the data in such way. So each cell value should contain only single value. There should not be multiple value in a single element, a single cell. This is another thing which we should be avoid by, that things we need to check. And there is another thing I just mentioned it. Each of the records should be unique in nature. Okay, let's see. Over here you can see this row is having this element. There are two elements over here, two elements over here. They are learning two different courses, A1 to A13. Here as well, the particular student Raj, he is learning these two courses, A11, A14. And they're paying, he is paying 500 and 700 as a course fee. Okay, so first we are eliminating this thing. Okay, if we are eliminates this thing, how it looks like? It will be just having this one. Okay, then we need to remove multiple elements from a single cell. How to do this? I'm just copying this thing again. I'm inserting a new record, new row over here. Let me just, okay. So I'm just putting only one value over here and removing A13 from here. Okay, so I need to also remove this thing 300 from here and putting it over here. Okay, and let me repeat this thing. Okay, so I just splitted this thing into two different row, 12 Sonu, A1 to 800. We are just moving to make it a first normal form data now. Okay, the same thing for this row as well. Let me insert another record, another line. Basically, I can say, so let me copy this thing, A14, it should be 700. Now I can say, you can see none of the records are duplicated over here. Each of the row, they're signifying different topics or different things over here. Okay, so we can now confirm this particular table is first normal form. We are moving ahead with first normal form. This is totally denormalized data. We remove duplicates as well as we remove multiple elements into different row. Till now, any doubts so far? Anyone? We are good to have the first normal form data now. As there is no response, I believe yes. So now we need to move ahead with second normal form. As of now, we can think if we are moving to the second normal form, then we are normalized in nature. The data is normalized in nature. Second normal form is very important. So what is second normal form? While determining the second normal form, we need to check the primary key of this table. So at first we can determine this is the primary key, but now we cannot say that this is the primary key, because each of the student can take multiple courses from the coaching center. So student ID can be repetitive over here. So student ID alone cannot be a primary key in this data set. We can say student ID and course ID. The combination of two column can be primary key over here. Just think about it. There should not be repetitive with the combination of student ID and course ID. Then that should be duplication again. Okay. So here is the concept of composite key. Composite key means when two or more columns can be signifying a primary key of a particular table, that should be composite key. So just like student ID 11, he is learning A11. Okay. So the combination of 11 and A11, you can see it's not repetitive over here anywhere. Just like 12, A12, it's not repetitive. So just think this composite key is the primary key of this first normal form data set. Okay. Now we need to go ahead with second normal form. For the second normal form, the important aspect is we need to remove partial dependencies. So in first normal form, what is the data set? The first criteria should be the data should be always in first normal form that I mentioned. And the second condition is there can be multiple columns in the same data set. We need to check whether all the columns is totally dependent on the primary key or not, whether there is any partial dependency exists with the primary key. If yes, then we need to remove those columns from this data set. We need to create another data set from that particular point of view. Let me show you. So we are here in first normal form. This is the same data set I have also copied over here. Okay. So over here you can see the last column, course fee. Course fee do not have the direct relationship with the student ID, course ID. I mean, we can have a quick mapping with course ID. Course fee is totally dependent on course ID. Each courses should be having each course fee. Each course ID should be having a particular course fee attached to it. So if anyone is learning A11, he need to pay 500. He or she need to pay 500. If anyone is having learning A12, he or she need to pay 800. So I have splitted course fee column from this table data set. Rather, I put it over here in this way. When I was putting this thing, the data should be in this manner. But if I just splitted it over here, you can see there is also duplication, just like A11 500. So I remove those duplicate and I make it in this way. Okay. So what I have done, I just eliminated this column course fee from this data set. Rather, I just took what is the immediate dependency of course fee column. This is only course ID. It's not dependent on student ID. Okay. So I just splitted this course fee from here and I just kept it separately with course ID. It's a separate table course. Okay. I can put course fee table only. Okay. And the mainstream, I just put it over here. There is student ID, student name and course ID combination. I keep course ID over here. This course ID is helping me to set relationship between these two tables. Okay, there is common column course ID. So when I request, maybe I am the principal of this coaching institution. I need to check how much Raj is paying to me, to my institute. So only this table will not satisfy my issue. I need to set relationship between this course ID and this course ID. I need to join this course ID and I'll retrieve course fee from this table to there. So I need to check Raj, his course ID is A11, A14. I just need to keep it A11, A14, 500 and 700, summation 1200. So Raj is paying 1200 to my coaching institution. Okay, so both of the table is signifying. This table along is signifying these things, but this is not normalized in nature. I need to split these things over here and I need to store these things this manner. Okay, so these things we can now tell this is normalized in nature. This is second normal form as well as this is also normalized in nature if we store this kind of data in database. Okay, so the entire process, I mean, I think Irfan, you were asking why we are requiring less space, correct?
Excuse me. So like course
Yeah,
ID is a foreign key here.
course ID is, I mean, over here it's foreign
It's a
key
foreign key.
as well as this is also performing as a composite key with combining with student ID and course ID, as I mentioned that time. And it is also
Mhm.
working as a foreign key as well. Yeah,
Okay.
but course ID is the primary key for this table only. I mean, I mean, course fee is totally dependent on course ID. And there is
Mhm.
unique, I mean, course ID is unique over here. So course ID is primary key over here. And over here, it's a foreign key.
Okay.
Irfan, you were asking how the data space can be minimized. So the first thing, we are removing
Yeah.
duplication. Removing duplication, that is removing, I mean, lots of records. Okay. And table space means, I mean, when we are storing large number of tables. I have another example over here. Suppose this is a big table. Okay. Not sure whether it's visible for everyone. Okay, we have a big table. This is a, I mean, it's in first normal form, but it's not totally normalized because there are partial dependency. Each of the table is not fully dependent. This is another example. Just check it, then we can also discuss again. So I just prepared this example as well. Okay, so we have order ID, customer name. This is the particular data set we get from a shopping mall. Let's say shopping mall. Order ID, customer name, customer contact, customer city, product name, product brand, billing cost. Okay, so we splitted this thing. There are maybe customer name is there is no such direct relationship with customer and order or customer name with product name. So why we should keep everything in a single table? Even this kind of table will took large spaces. Okay, so we can remove partial dependency and create small table, just like order table. It will be only consisting relate only orders as well as the foreign keys. Okay, so order ID is consisting of order ID. Okay, let's remove the order table from the mind now. Let's create our dimension table. What is dimension? What is fact? I'll be repeating this thing later. But just think customer table is a dimension table or product table is a dimension table. So we are creating customer table having all customer related information. These three column. And we are imposing one primary key for customer table, which is customer ID. Okay, customer ID was not mentioned over here, but we are introducing a new column, customer ID over here. Similarly, for product table, we are putting product name, product brand, and we are introducing a new surrogate key. It's called product ID, which is the primary key for this table. Customer ID is the primary key for this table. And in the order table, it's a fact table. What is fact? I'll be telling later during our business intelligence chapter. But just as of now, remember this is a fact table. This is dimension table. This is dimension table. In order table, we are maintaining order ID, this one. We are maintaining billing cost, this one. And to set relationship between these two table, we are keeping this customer ID over here, this product ID over here. Those customer ID and product ID are foreign key in order table. Okay, so this is another suitable way to store the data. And we are maintaining in the same format when we are storing the data in data warehouse. Okay, so it's normalized in nature. It's in second normal form. We are splitting the data set into this manner to remove partial dependency between various columns. Okay, there is no such direct relationship between customer city and product name. Customer contact number and product name. There is no relationship. Why we should keep this thing in a same table? So that is the reason we are doing in this manner. Okay, so this is how relational database, we can store the data efficient way in relational database. That is the way we are doing. I mean, we are storing the data in relational database in normalized in nature. Okay, the concept is clear.
So
Yeah, Irfan,
yeah,
tell me.
my my question is like what this process we are doing data normalization of data.
Mm-hmm.
So can we say that it is a kind of cleaning the data?
Yes, of course. We are cleaning the thing. We are cleaning the thing. We are storing the thing. I mean, in a suitable or efficient way. Of course, we are cleaning it. Uh,
Okay, I got it.
Otherwise, the duplication should be the duplication. Things actually. When you will be working in a live project, maybe there will be ERP system in a live project. We are. I mean, the data engineers are taking data from the source system. Okay, the source
Yeah.
system can be a mainframe system. It can be a web page. It can be ERP systems and all. Their users are inputting the data, and you can see the data we are receiving OLTP systems, and you can see there are lots of duplicates are there. I mean, lots of duplicates. Users are, I mean, inputting multiple things. Okay, so first we need to clean all those things. We need to remove the duplicates. The first thing is this removal of duplications. The same users are putting multiple forms in examination by their email registration, but only one registration they will be go ahead with fees payment. Okay, so this kind of multiple registration from a single user can be treated as duplicated entries as well. So, but when storing the final data set, we'll need to keep this thing in mind. So that is the thing. The first thing we need to clean the data while make it a normalized one. And after that, we'll be doing this kind of partial dependency removal, which will be helping us to store data in small table, in fact table, in dimension table. Each of the dimension table should be having a primary key in this way, and the fact table should be having its own primary key as well as the foreign keys of other dimension table, so that we can set the relationship between each of the tables. That is why it's called relational database. Okay, but the concept is very important. In later chapters when we'll be learning business intelligence, this should be helpful for us. Okay, the next slides we already covered, but let me quickly repeat. The keys in SQL, the keys we told, the primary key in each of the table, it's uniquely identify, it's to quite, I mean, it's unique in nature. It should be helping us to identify a table's record. Composite key, composite key is nothing but it, I can also say it's a primary key, but when multiple keys will be there to determine a particular row's identity. Just like I told that time, the combination of student ID and course ID can be unique in nature. That can be helping us to identify a particular row. That is called composite key. Foreign key I just mentioned. When we just want to set up relationship with another table, there should be there should be common columns between both of the tables. So the primary key uh, from one table can be put into another table to set up this relationship. So the particular key when we are putting into other table, that is called the foreign key. Okay, it's a key that references the primary key into another table. So just remember it, because this is the main structural things to create relational database. Okay. Now I'm entering what is database. I mean, just like in this example, I have shown these things in a particular Excel sheet. In Excel, I am maintaining this thing in tabular structure. This is relational database tables, I can say. But in our project, we should not be identifying or we should not be storing data in this kind of Excels, because there should be lots of data. We need to handle maybe thousands, maybe millions, maybe billions of records there. So we cannot store the data, we cannot insert that data in Excel sheet daily basis. There we need to maintain a database. So in last working day, I told you to install MySQL database. Let me open the database from my side. I hope you have installed this thing, because this is open source. We'll be going to demonstrate the same database from tomorrow onwards. So whoever did not install this database at your system, please install this thing. I'll be just quickly pasting the link again. Okay, so this is a particular UI to access the database. The database is there in the backend, and the UI is MySQL Workbench. The database name is MySQL. Okay, there are lots of databases are available in the market. So I just mentioned the thing over here. There are MySQL, Oracle, Microsoft SQL Server. It's a Microsoft product. Teradata, Postgres, Sybase, DB2, Redshift, Snowflake. There are lots of databases are available in the market. Okay. Over here we choose this kind of MySQL, but if there is any database which is installed in your system, that is fine. We can go ahead with that stuffs as well. But who are quite new, who did not install anything, you can install MySQL database at your system. I put the link there. Let me just put it again. Okay, so this is the link. Just download the second one, this one, and install in your system. Let me tell the link once more time. Who haven't installed, please install this database. And after installing the database, this kind of UI will be also installed with it within the package. It's MySQL Workbench. By this UI, when we will be opening this UI, you can see in the left hand side, those are called database schemas. So when we will be storing the table, we can choose any one of the schema. It's called database schemas. Okay. Just like over here, we have new schema test. We can create new schema as well. Just right click over here, create new schema. Okay. Just put anything, new schema. It's fine. A new schema underscore 1234. I'm just putting it over here in this manner. Or we can also put this command. I'll not be, telling what is the command, because tomorrow we'll be learning the coding part and all. So you can just click on apply. You can see a new schema has been created for us. What is database schema actually? Those are called database schemas. But what is database schemas? In database schemas, we can create our tables. Just like in this schema, I have created these tables. Just I'm expanding these tables. You can see those are all tables I have created. In customer table, if I just check the data, I can see there are lots of data. Okay, so those are different record in the table I have stored in my previous session. Okay, so I have created those different tables inside this database schema tetra data underscore training, and those are different tables I have stored it over here. So the similar kind of things we'll be learning over here from tomorrow onwards, learning the SQL command line from here. But just to let you know, when we are opening any database, in the left hand panel, we can see the database schemas. Each of the schema, we can store our tables. Why there are different schemas? Specifically for different subject areas, we can put. Suppose I'm maintaining uh, maybe a banking systems database. Okay. So there I have created a database schemas for credit. I have created one database systems for debit. I have created one database schemas for card related information. So there are three different schemas. So all required tables, maybe all the tables for debit related information, I have put in debit schemas. All the information related to card related stuffs, I have put it card related schemas. So this is the thing. We can create different schemas for different subject areas. So each of the tables is required for which subject areas. I can segregate the things over here in this manner. Okay, this is the thing. In the left hand side, you can see administration. This is especially for the database admin team. Actually, there should be a separate team who can control the database administration. The team is called DBA team. Okay, they can control the access part of database engineers or any support members or any data analyst or any data scientist. What particular access they required, what particular table they needs to access, what particular schema they need to access. They will control it from this administration things. Okay, as I have installed this thing into my local host, I am the admin of this tool as well. I am the database engineer as well. So I can manage all the thing from my side. But in a live project, there should be a separate DBA admin team. Okay, Irfan, you are trying to fetch something.
Yeah, I just shared the screenshot of MySQL. This is what it's showing when we open for the first time.
Yeah, just click on schema. You are in administration tab. The same thing I was just telling. Okay. Uh, you can click it over there. So you can see the schemas and all. So it's fine at your system. You are successfully able to install the database. It's fine, Irfan. Okay.
Thank you.
Yeah. So I was just mentioning administration tab is for administration purpose. We did not require these things as of now. We only focusing on schemas part. But this is especially suppose you want to update any patch. Okay. Update any patch of this database, patch of the software, because for some security vulnerability issue, you need to update the patch. So there you need to export the data first. All the tables you need to export and you need to keep it stored. You are updating the patch. Whenever database is up, then you need to import all the tables again. So this kind of admin related activities can also be done, this administration part. But as of now, we do not need to think about it. We'll be only focusing on the data. We'll be handling the data only. So we need to focus only the data part. Okay, so who have joined this class as the first day? So please install this kind of software. I just pasted the link for MySQL. You can install MySQL. This is very lightweight and open source free software. If there is any other software are there, you can also try the same thing. Anything you can do, but please install this thing because tomorrow onwards we'll be learning SQL. We'll type our own query language. So when I'll be trying the same thing, you can also try the same thing at your side. We'll never be stuck. Okay.
Do I need to
Yes.
sign in for SQL
No,
or
no.
directly we have to download?
We need to download it. If they are
Okay.
telling you need to sign in the, just scroll it down. You can just get the option skip and download.
Okay.
And
Okay.
while installing it, you will be downloading it. While installing the same, first time you need to configure the database password as well. I told these things last working day. So while configuring the database means while you are installing the database, it will be asking for a password. Don't forget the password, because each day when you will be logging into database, the password will be required. In my previous session, they have configured it. The students configured it, but they forget the password. Then they need to reconfigure it again. So just whatever password you are putting, just remember it daily basis when you will be logging the instance. Suppose you are closing this instance, you are going to log in it again. So each day they will be asking for the password. Okay. So I hope this is fine for everyone. Please install it. Okay. What are the other things?
Yes. Thank you.
Yeah. Yeah. Okay. One more important thing. Maybe when we are live in a project, we should not be working in MySQL. We can be working MySQL. There should be separate database. Suppose you receive the project maybe on Redshift, maybe in Snowflake. So almost the code is 90% same. Whatever code we will be writing in SQL, it's the functional thing is totally same, but the code is not totally matching for each of the database. The main base things are same. The main SQL language is same, but there should be some inbuilt functions for each of the databases, which can be syntactical different. There can be a bit different. Just like when we are doing concatenation in MySQL, this is a bit different with Microsoft SQL Server. So some of the inbuilt function syntax are different among each of the database, but do not need to worry about it. When you are functionally strong, when you know SQL, then you can search for it in web, what is equivalent functional syntax for another database, and you can quickly get it from web. No need to worry about it. You just need to have functional strong on SQL. For different kind of things we can do in SQL and all. So that thing we'll be learning over here. But when we'll be working in a separate database, this main SQL stuffs are same. Just the only change is some of the inbuilt functions that can be have a different syntax. That can be or that cannot be as well. Okay. But do not need to worry about it. So I mentioned what is database schemas that I mentioned over here in this left-hand panel. Those are different database schemas. I can make any one of the database schemas as my default. The default one is having bold in nature. So whatever command I'll be writing over here, that should be occurring in the, that should be happening, or that particular query should be executing under these schemas. If I make anyone as the default schema, just right click on it and set it default. This is another way. Or I can make in my command line itself, whatever command I'll be running or executing, I can mention I need to execute this thing under this schema. I can also mention in this way. Either way, we can do this thing. But as of now, in over here, I just make it as a default one. While running the query in the, the next day, maybe tomorrow, when I'll be writing the query, I'll not be specifying any of the schema. As I have make it a default one, all the operations should be occurring over here. So you can do in the similar way. I'll be telling the same thing again in tomorrow's session. Okay. So when we can expand one schema, let me go to the next steps. Database objects. So when we will be expanding any one of the schema, we can see those are different database objects. Table, views, store procedures, functions. Okay. Those are different database objects. Table is the basic unit. As I mentioned in relational database, table should be the basic unit. When we have all our tables ready, we can create views, we can create store procedures. So those are also different database objects or components. First, we will be learning on top of tables, how to create tables, how to insert data in the tables, how to manipulate data inside the tables, how we can go ahead with different select criteria. I mean, different visualization on top of the tables. We'll be learning these things. When all the things on top of tables will, I mean, we are completing it. We'll be learning views, how to create view, how to create store procedures. So those are also database components. It's a bit advanced level or intermediate level, we can say, but we need to first learn the SQL query on top of tables first. Okay, but just to mention, those are all different database objects. It's not only tables, there are views, there are materialized views. Some of the database they're supporting another component called materialized views. It's not over here, but I'll be mentioning during our class. Okay. So those are different database objects. Yeah, the classes I'll not be starting SQL from today. Tomorrow we'll be learning SQL. We'll be, I mean, writing the SQL codes over here and we'll be executing the codes and we can get the output over here. Okay. So please install this software and can have the hands-on part from tomorrow onwards. We'll be learning and doing the hands. Any doubt so far from anyone? We are almost end of the class for today's session. Any doubt on normalization process from anyone? Any doubt on database installation? Whoever tried but did not able to install it. Irfan, you have already installed, so if anyone requires any help, you can also help them
Sure.
for the installation part. Yeah. Someone got stuck. As per my previous experience, I found. So you can also, anyone can get in touch with Irfan. Okay. As there is no doubt, I hope it's fine. But if there is any kind of doubt, please tell me over here. Okay, so make the database ready at your system. We'll be starting our first query from tomorrow onwards. We'll be learning the programming language on top of SQL.
Like I was looking for the recordings. Like today is the first session, so I was looking for the recordings. So where can I get the recordings?
Okay, so I have provided the first day's recording to someone, and I told them, okay, you can put the same questions to the WhatsApp group. Someone, I mean, some admin team member is storing the recording into some YouTube links. So they can give you the YouTube links. Okay.
Okay.
So just post the
Okay.
same question. The admin team, the admin person will be responding over there and they can help
Okay.
you the updated YouTube link. Only one day class has been covered. So the first day class they will be giving to you. Okay. So as the class is totally, I mean, starting with basics, I hope there is no issue while understanding. But if there is anything from anyone, please ask me question. Otherwise, I mean, the same thing will be required again in the next session. Then you will be stuck to understand what is primary key, what is composite keys and all. Okay.
Hi, Sautik. I have a small question. Like we
Yeah,
dealt
Vishnu.
with the first normalization form as well as the second normalization form. Where the second normalization form, we are eliminating the partial dependencies in the data set and creating, independent tables as dimensional as well as facts tables. Then how about the third normalization form?
Yeah, third normalization form, I haven't covered it over here. So
Yeah.
as of now, yeah, second normalization form is fine. I mean, for the basic
Okay.
things as of now. Yeah, there are
Okay.
3NF as well. Yeah, this is
Yeah.
for everyone. Yeah, that is a good thing. So 3NF is also available, but from second normal form onwards, I mean, most of the projects we are going ahead with the second normal form. I mean, it's fine to say it's a
Okay.
it's a normalized one, but there is third normal
Okay.
form as well. But it's not very much important. But you can just, I mean, it's also important But I mean, for the basic things or intermediate things, it's not so much important. We are good to go with second normal form. Okay. But there is also the higher normal form existed. Third, fourth. Okay.
Okay, fine.
Okay, then. Thanks, everyone. Thanks for your time. Let's connect tomorrow with our hands-on session. Thank you. Bye-bye.
Thank
Great
you.
and Merry Christmas to
Thank-
all of you. I
Thank
just
you.
forgot to write.
Thank you.
Yeah.
Thank you.
Thank you.
Thank you. Thank you, everyone.